This is lab 2 as it applies to Newton's second law with non-zero net forces. So for this lab I dropped a small light ball down a staircase and I used a white background to improve contrast. I used the lightness of the ball along with the length of the staircase to try and give more data points. And as we can see, I align the axis along the direction of the motion for ease of use. This results in this graph here, and as we can see, we've got a little discrepancy as the graph curves over to the right where it should not. This is because of this bounce here towards the end. I then used this data here to make the VPython file. I inputted all the important data such as the ball's mass, starting time of 0, I've got the ending time, 0.672 seconds, and then I inputted the forces, the weight force and drag force, and these make up the net force. And over here I've got Newton's second law, as well as the position variant of the law, and I also added arrows to show the forces more easily in the demonstration. Here we see that the weight force stays constant and the drag force increases as the ball's velocity increases, because the drag force is proportional to the square of the ball's velocity. I then used both of these data to make a graph over here of the observed versus predicted position. As we can see here, there is a difference as the predicted motion is curved below the observed motion. This is because the predicted motion accelerates quicker. This is probably due to the ball's mass being larger than it actually is. So I would need to use a more precise mass measurement to improve that, so that the ball would curve a little higher, closer to this observed position. Now, the what-if questions. They have to do with terminal velocity. Terminal velocity is, of course, from the drag force equaling the force of gravity and canceling out, making zero net force, which is constant velocity, which is why the graph starts becoming linear towards the end, as you can see right here. And so, yeah, that's terminal velocity. If I had thrown the ball, it would have started at the same place at the origin at 0, and it just would have reached terminal velocity faster, and it would have become linear quicker. So it would have started here and curved down just a little bit, and then become linear very quickly right about here. But it would still reach the same terminal velocity. And that is all.